Saxon Advanced Mathematics, Lesson 82. Our topic today is logarithms, and we're going to learn to do something slightly new with them that is fun. We're going to skip all of John's theoretical prelude and jump right into the problem, and I will tell you exactly what you need to know. 82.1, solve. We're asked to solve. Okay, John, we'll do what we can. We will try. And this is what we're given. I'm going to use double lines. 10. Look at that exponent. Look at that fearful exponent equals 8. Okay. What this problem is asking us to do is find an exponent that we can put on 10 that will give us 8. What? That seems impossible. And what's really tricky is we have a variable in our exponent. That is a huge clue as to how we want to move forward in this problem. If we could turn this into a log, then we could use the power rule for logs, and we could take this off and put it as a lead coefficient thing, right? We can put it down in front, right, of our log. That's one of our rules. So that's what we're going to do. It's an operation that's called taking the log of. And we can do it just like we can do anything else. We can raise things to a power. We can take roots. We just have to do it to both sides. So this is called taking the log of, and we're just going to say log 10 of the minus 2x plus 2 equals log of 8. The exponent that you put on base 10 is invisible there, right? The exponent that you put on 10 to get that, 10 to that, is equal to the log that you put on 10 to get 8. Yeah, that's this problem. It's the very same problem. So we're allowed to do that, and it's called taking the log of. And again, the big hint was this exponent in the variable. Okay, now to simplify this, we can take this off, right? We can write it like this: minus 2x plus 2 log 10 equals log of 8. Isn't that amazing that we can do that? It's beautiful. Now, what we can do is we can do two things at once. And let's talk about the easiest one. We can use calculator to get a value, not a valuable, calculator. We can use the calculator here to get a value for that, and it is 0.9031. Okay, that's on your calculator. Make sure you can do that. I'm sorry, I can't show you right now. Okay, and then the other thing we recognize is that this is equal to 1, and I'll explain that to you in just a second. Okay, that stays the same. All right, so this, we used our calculator to simplify. This came along for the ride. What is the exponent that you put on the base of 10 in order to get the number of 10? 1, right? Let me just write that over to the side. That's kind of like 1 times 1 is 1, and it's so simple we can't barely think about it. If the base is 10 and the exponent is 1, no, if the base is 10 and the number we want is 10, then the exponent that you put on the 10 is 1. So this can be simplified to 1. Now we have minus 2x plus 2 equals 0.9031. I want to make sure I copied that right, because that would mess up the problem, right? Would be very sad. Okay, That's correct. And now we just do some basic algebra. We subtract 2 from both sides, and that will get us minus 2x equals, what is it, minus 1.0969. Right? And then we divide both sides by minus 2, and we get x equals 0.5485. The numbers got a little sloppy because when we simplified log of 8, we introduced all these decimals, but it's not that big of a deal. This is our final answer. Right? So just reviewing, the hint we knew that we wanted to take a log of both sides was that we saw a variable in the exponent. And we thought, how are we going to get this down? We don't want it in an exponent. And then we realized if we take the log of both sides, then we can use that power rule to take this and jump it off and put it in front. Remember how I told you when we were first learning the laws of logs that this power rule was the weirdest one? And that sometimes we'd take this and want to jump it up here, but other times we would want to be up here and jump it down. This is an example of the former. All right, let's do another one. There's 4 examples in this lesson. Example, I'm getting close to the end of this book. 82.2. All right, and our problem is solve don't let this scare you. E, that's an E. That is, it looks like an L. It's an E. E to the minus 2x plus 3. Yes. That's a better E. Equals 5. Okay, remember how last time we had 10, and that gave us a really good hint that we should just use a log for that, right? Because then that would become a 1. This one is going to be the same. We see the exponent in the variable. Oh, I said that wrong. We see the variable in the exponent, and we say, aha, let's turn this into a log problem. We want to take the log of both sides. But we want to take the natural log, right? We don't want to use the base 10 log. We want to take the natural log. That was what my brain was doing before when I made the loop there. Because then this will cancel out to a 1, just like we did last time, right? So I take the log of both sides. I take the natural log of both sides. Now I pop that down. Minus 2x plus 3 times the natural log of e equals the natural log of 5. And we do everything the same that we did last time. We use the calculator to find that. And that value is 1.6094. This comes straight down, minus 2x plus 3. And we recognize that this equals 1, right? What the base is e. So what is the exponent that you put on e to get e? 1. Okay, it's the same little trick. So the natural log of e equals 1. Just like we said on the other page, the log of 10 equals 1. Good to know. All right, so now we can simplify this and we get minus 2x plus 3 equals 1.6094, and then it's exactly the same. We just subtract the 3, and this will be minus 2x equals, let's see, it's minus 1.3906. Right? 0, 1, 1, 1. Yes, okay, that works. And then we divide both sides by minus 2. And we get x equals 0.6953. Right? Once we get to this stage, it's pretty easy. Okay? Identifying that variable tells us to take the log of both sides. Looking at this base gives us a really great clue on which type of log we want. Okay, 82.3. Oh, that's why I didn't adjust my light tonight. I'm having a really hard time reading the book. It's like, what is my problem? But I don't have the light on it, so that would explain it. All right. Solve 5 to the 2x minus 1 equals 6 to the x minus 2. Okay, now I don't see a 10 or an e here, so technically we could work this in either base, right? Either the common log of 10 or the natural log of e. But for the most part, we feel comfortable using the natural log. That's my preference. So what we're going to do is we're going to take the log of, and we're going to apply the power rule at the same time, right? Before we were doing them in separate steps, we're going to do it in one step now. So it's going to be quantity 2x minus 1, that jumps down, times the log of 5 equals quantity x minus 2 times the log of 6. Beautiful. Now, this time, we don't have either of these cute little tricks to help us in our simplifying. So we just have to use the calculator to simplify both of those. I'll give you the values. So we'll have, it'll still be the 2x minus 1, and this will be 0.6990 equals, and then this will be x minus 2, and then the log of 6 is 0.7782. Okay, now we just have icky multiplications to do, right? Because we have these big decimal numbers. But I don't feel too bad because you may use your calculators to do all of this, all right? What you'll get when you distribute is you will get 1.398x minus 0.6690 equals 0.77. I'm just distributing. Minus, okay, I'm going to have to go to the next line. I'm horribly sorry. 1.5564. Okay, simple distribution. Now we will swim. Wait, I forgot. One of these needs an x. Oh, the first one does, right? Yes, I forgot the x. Okay, so let's subtract the 0.7782 from both sides, x, minus 0.7782x, and then we'll add that one. So those cancel, those cancel. Oh, that's so sad. And this becomes 0. And we add these two together, it's going to be 2.1 something or other, right? No, that's a minus. Right? Because this is a minus, so that's a minus. Okay, so when we combine them, we get minus 8574. I had the minus sign. I just wrote it on the top row instead of the bottom row, so it looked confusing. Note to self, right? When you have to go onto a second line, put the sign in front of it. Okay, and then our last step. This part is easy. It's just laborious because we're working with big, icky decimal numbers. There's our x. We use our calculator to do that, and our final answer is x equals minus 1.3833. So interesting that the hard part does not require the calculator. And then the part where we use the calculator is here to find the values for these logs that don't cancel out beautifully, and then to just do the tidy work there at the end. All right, and I do want you to go ahead and work them with 4 decimal places. We don't usually do that, but I want you, now that we're, 2/3 of the way through advanced mathematics, I think it's okay to ask you to do this. In college, very often, your professor will tell you, if he doesn't or she doesn't, ask, how many decimal places do you want the answers to? But I think it's good practice for us to do a few. Okay, one more. These are kind of fun, aren't they? Because it's like, ooh, it looks like it's going to be such a hard problem, and then you just cleverly trick it into working nicely for you. 82.4. Solve. 4 equals 6e to the 2x plus 3. Oh, okay, well, that's fine. That's what we're starting with. Now, this time we can see that what we want to do is we want to use the natural log because we've got an e in there. So we're going to take the natural log of both sides. And I'm putting parentheses around this whole thing because it's a bit of a mess, isn't it? And we want to make sure that that all gets included in there. Okay, now, when we're multiplying, before we take this down, I want to resolve this. When we're multiplying these together like that, it means this 6 and this e are being multiplied together. That means we use the product rule. That means we can use addition to break them apart. Let me show you what it looks like. This side stays the same. Equals the natural log of 6 plus the natural log of e to the 2x plus 3. Okay, so that is the product rule at work here, right? If we're multiplying, we can break them apart and use addition. Okay, so we'll keep on trucking. And now I'm going to pop this down. Okay, the natural log of e, oh, this is one of those tricky ones. I know that's equal to 1, right? So I'm going to change that into a 1. This 2x plus 3 is going to be the same. And then the natural log of 4 and the natural log of 6, I'm going to use my calculator to get. Natural log of 4 is 1.3863. And the natural log of 6 is 1.7918. And that's plus. All right, the 1 goes away, right? I don't even have to distribute it. And so now it's just a calculator game. I'm going to subtract the 1.7918. And the parentheses can come off. I'll also subtract the 3. So that'll be gone, that'll be gone. I'll still have the 2x. But this will be minus 3.405. 5 is what John says. Yeah, that makes sense. I think that works out properly. That equals 2x, and then we'll divide both sides by 2. And we get x equals minus 1.7028. Remember that these answers that we get, they don't really have a lot of deep meaning for us. They're just, okay, that's the value of that. I mean, okay. What's more important is that we recognize that taking a log of is a strategy we can use. It's an operation, you guys, just like adding or subtracting. Taking the log of something is useful when you have exponents with variables. That's the key, all right? And then we've got a couple different tools we use to simplify. I hope this makes sense. I think this is kind of a fun lesson, and it's one that I hope makes you feel really, really smart when you conquer it. I will tell you right now, though, that lesson 83 is a cute little probability lesson that will give us a break from the rigors of this monstrous calculator-driven beast. All right? Lesson 82 is history. Goodbye.